So you are welcome. We are looking at functions that we cannot differentiate directly. We have to use an approach to go by to get the differential of such function. And that approach that we use in the differentiation is called the implicit differentiation. So to be able to perform implicit differentiation on an equation that defines the dependent variable y implicitly in terms of an independent variable x, the derivative of both sides of the equation is taken. So, for instance, given an equation as x cubed plus y plus 3 is equal to 5x, and you have this function and you are asked to differentiate the function. We don't know the dependent variable explicitly. We don't know it directly from this function. So we are supposed to use the implicit differential to go about to find the differentiation of this function. Now let's look at a rough method of how we go about with the implicit differentiation. So taking this function x cubed plus y plus 3 is equal to 5x. Now we differentiate, or we take the differential of both sides of the equation. Take the differential of both sides of the equation. So we differentiate x cubed plus y plus 3. Then we differentiate 5x separately. Now we take the differential of that, the differential of this. So now on the left side of the equation, we have 3 terms in brackets, which the differential is, and we have just one term on the right side. So now on the left side, you're supposed to break all the terms and differentiate them separately. You're supposed to break all the terms and differentiate them separately. So if we had same for the right side, we would have done same for it. So if you have more than one term on each side of the function, you're supposed to break them, then differentiate them separately. So now we differentiate x cubed, differentiate y, then we differentiate 3. Then on the right side, differentiate 5x. So with the separate differentiation, we differentiate x cubed, then we're having 1, which is the coefficient, we separate it. The exponent becomes the coefficient 3x to the power 3 minus 1. Then now we differentiate y, then we differentiate 3, then differentiate 5x, differentiate 5x. So with the 5x, we separate 5, then we subtract 1 from the exponent. Then with the y, it had an exponent of 1 and a coefficient of 1. We separate that, then we subtract 1 from the exponent. Now, since y is the dependent variable, after differentiation, we multiply that differential by dy dx. Since y is the dependent variable, after differentiation, multiply that term by dy dx. So if the function has 2 or 3 terms, after differentiation, all those y terms, you multiply the terms by dy dx. So we take note of these two. So after the differentiation, we're having 3x cubed plus 1 multiplying dy dx, which is equal to 5. Now we know that any variable or number to the power 0 is 1. Y to the power 0 was 1, which we had 1 multiplying dy dx. So now after this, then we make dy dx the subject, leaving us dy dx equals 5 minus 3x squared. 5 minus 3x squared. So this is how you go about using the implicit differentiation to find a function which cannot differentiate directly using the normal differentiation approach. So now let's look at some examples and how we go about using the implicit differentiation to find their differential. So the first question is, assuming that y is defined implicitly by the equation x squared plus y squared, which is equal to 25, find dy dx. So this is the equation we are using. X squared plus y squared is equal to 25. So now let's solve it together. So firstly, we differentiate both sides of the equation. So x squared plus y squared differentiated, then 25 will be differentiated. So on the left side, you're having 2 terms. So we break, then we differentiate separately. On the right side, it is just a term. So we go by that. So on the left side, you're having x squared, we differentiate that. You're having y squared, we differentiate that. So with your differentiation, you're having 1, which is the coefficient of x. We separate it. Then we bring the exponent of x to multiply x, which is 2. So you're having 2x 2x exponent 2 minus 1. Then we do same for y. We separate the coefficients, we bring the exponent to multiply y, then we subtract 1 from the exponent. Then we add dy dx to it. We add dy dx to it. Since the term has y, we add dy dx to it. Then on the right side, we're differentiating the constant, which in turn gives us with 0. So after the differentiation, we're having 2x plus 2y dy dx, which is equal to 0. 2x plus 2y dy dx, which is equal to 0. So now we are supposed to make dy dx the subject. So with a change of subject approach, we send 2x to the other side of the equation. We send 2x to the other side of the equation. Then we divide 2 by 2y. Divide 2 by 2y. So we divide the left term by 2y, then the right term by 2y. Then we simplify, we cancel the 2 out. Therefore, leaving us dy dx to be equal to minus x over y. Minus x over y. So this is how you go about to use the implicit differentiation to find a function that the dependent variable is not implicitly determined. Now, the next question is, assuming that y is defined implicitly by the equation sine x cubed plus y is equal to 4x squared plus 3, find dy dx. 4x squared plus 3, find dy dx. So now let's look at how we solve such problem. So firstly, look at the equation. There's a part that we are supposed to apply chain rule because we're having two different terms multiplying. Supposed to apply chain rule and put that two at the same time. So we go about how we use all these terms, then all these approaches to solve this function. So in the solution, we differentiate both sides separately. So both sides have more than one term. So we differentiate them separately. So differentiate the left side, sine of x cubed plus y. Then we differentiate the right side, 4x squared plus 3. So with the differentiation, we break all the terms. So we're having sine x cubed, differentiate that, differentiate y. Then on the right side, differentiate 4x squared, then we differentiate 3. So onto their differentiation. We first tackle sine of x cubed. So we replace x cubed with u, which means we are applying chain rule to this part. So we replace this with u. So after that, we differentiate it. So the differential of x cubed is giving us 3x squared. So after differentiating this, then now when we differentiate sine u, differentiate sine u. So after we are done with u, we differentiate y. So we make y to be equal to sine u. We make y to be equal to sine u. So after that, we differentiate y with respect to u. So we are having dy du to be equal to cos u. Since the differential of sine is cos, so therefore dy du is equal to cos u. So after the differentiation, we therefore put the separate differentials together using the chain rule equation. We know that dy dx is equal to dy du times du dx. So we put them together. So now we bring the chain rule to replace this part of the equation. We bring the chain rule to replace this part of the equation. So dy du times du dx plus the differential of y, the differential of 4x squared, then the differential of 3. Now we know these differentials, so we just replace them, then we differentiate the others. So we know dy du to be equal to cos u, then du dx to be equal to 3x squared, as we done earlier. Then we differentiate y, then we add dy dx to it. So the differential of y will leave us 1, which is the coefficient. Then we subtract 1 from the exponent. Then we multiply dy dx. Then the differential of 4x squared, we separate 4 from the variable. Then we bring the exponent to multiply x. Then we subtract 1 from it. Then differentiating a constant gives us 0. So after differentiation, we're having cos s cubed. So the s cubed is from the u that we replaced earlier. Then we have 3x squared plus dy dx. So the dy dx is from here. After differentiating the y, then we're having dy dx. Y to the power 0 is 1. So we're having this, which is equal to 8x, which is equal to 8x. So we subtracted 1 from 2, giving us 1. Then we multiplied 2 by the 4, giving us 8. Now the final answer for this derivative is 8x minus 3x squared multiplying cos s cubed. Multiplying cos s cubed. So this is how we use implicit differentiation to find such problems, and how we imply chain rule, product rule, quotient rule to such functions.